Hello all and welcome back. So in this video, let us now continue our discussion and now let us try to implement the rehashing. So we discussed in the last video about the complexity involved in our hashmap function where we understood about the load factor and the rehashing mechanism, right? So the idea is same that once our load factor become greater than say 0.75, then is when I will be doing the rehashing. Okay. We understood the whole concept, but let me reiterate that we will be making another buckets array which will be twice the size. Okay, so here it is not twice the size but should be fine. Let me make this one smaller, so somewhat like let's say this one. Okay, so once our original bucket array gets filled and the load factor become greater than 0.75, we are going to do rehashing. Majorly the change will be in insert code, but let us see if any other function will require changes or everything is going to work fine. Okay, so let us start with that, everyone. Pretty sure that you have understood the concept that why we need to do that for each and every key, right? So everything in this particular node of my linked list will have to go through the rehashing process. We cannot just directly copy this head. The reason is the key final bucket index will change because of my this particular capacity change, right? So let me write that down as well here. Though I think we have discussed the same. Let me write it in green. Yeah. The final bucket index will change due to capacity, right? So something like this is very, very important to understand, everyone. And let's just have a star on this so you never forget this. Okay, great. So now let us implement that, everyone. It's going to be pretty easy only, but I will make sure that each and everything is explained to you. Great. So let us go back into our code. When we are inserting, before returning, we should now calculate a load factor. Okay, I guess it is lambda in like books or somewhere. Okay, so I read it about in a book as well, so it was used as a lambda there, but we are just writing the load factor. Okay, so what will be the load factor exactly? Initially, what is going to be the load factor? I feel that it should be the overall size, that is the number of things which we have added, right? So self dot size, which we are maintaining by self dot capacity. Okay, once this load factor is greater than 0.75, we can make it as a constant as well outside depending on the use cases, but we are taking 0.75. We have to do something. Okay, let us call this one function which we are going to make. We have to do lots of stuff here, so maybe we can do the same here as well, but it's always better to just create it as a function. Okay, let us create def rehash and we just have to send the self. Everything is there. Okay, great. So before moving forward, everyone, let us just try to understand few things. Let us just try to print this as well. Okay, print load factor. So it's going to be load factor like this. Great. So yeah, let us try to add some elements. We are adding the elements. Let me take it as 2. We can add more element as well. Let's say banana 2, banana 3. And for the time being, let us just comment this out. Okay. So pretty sure that you must have done the get item as well. Set item we did. Great. And I can just get the length. Now, if we run this, everyone, see load factor 0.5, 1.0 because we have taken it 2. Let us take it maybe somewhere around 5. So 0.2, 0.4, 0.6, 0.8. This is where my load factor is greater than 0.75. Here, I believe hashing should happen to make sure that everything happens in a constant type, like all my operations are constant time operation. Okay. So let us now try to implement the hashing code, everyone. Load factor. Great. So this is where I have to now write the hashing code. Let me just zoom in, get rid of the output window. Cool. So now let us discuss what exactly do we have to do in hashing. Okay, what are the steps? So let me go to the whiteboard and let us see what exactly are the steps which we will have to perform in my hashing. Okay. First is that we should save this old buckets, right? We cannot directly say that, hey, my new bucket is twice the size. So we have to save this old buckets, everyone. Let me write it by above so we can refer to the diagram as well. First thing, save old buckets in some variable. So I will say that, hey, old buckets, you just point here. The buckets array, right? The normal buckets array, which was pointing here initially, I will say that, hey, cross this and please point to this new one. Okay. That's the very first, that's the two steps which we have to do, everyone. So second is going to double capacity. Doubling capacity is very, very important. We cannot just make the array. The reason is that it will be used in hash function going forward everywhere. Then we have to create a new buckets or ask the bucket array to basically point there. Okay, there is one more very, very important thing. See, we are creating everything from scratch now, right? So we have to make sure that size we are also making 0 because internally we will be calling the insert function. This will be clear when I do the same in coding. And yes, then we have to just for every entry, just insert. So these are the steps, everyone. Okay, so just writing them so that you are comfortable in understanding what are the steps involved. First, save the old bucket array. You cannot directly say that, hey, this is my new buckets. You will lose the access to the last one. Second, double the capacity. Then we will create from that function which we wrote, right? Create buckets function, we must have written the private one to create a new buckets. We have to also make sure that the size is 0. This I will touch upon in implementation as well. Once this all is done, then we just have to go to each and every linked list, make sure that we are traversing the linked list till we get none, and keep on adding each and every element. Okay, so let us now implement this, everyone. Great. So in the rehash, first, let us print that we are rehashing so that we get an idea that yes, rehashing is actually happening. It is not something which didn't happen. Great. Now, first thing, old buckets equals self dot buckets, right? Self dot capacity equals self dot capacity into 2. All I'm doing here is just doubling my capacity, something which we have done in dynamic array as well, right? So that is how dynamic array is also overall implemented. Then self dot buckets. Now I can reinitialize it because I have saved the old reference equals self dot, I think it was underscore create buckets. This time I have to just pass the capacity here. So that was the reason, everyone, I was passing the capacity initially as well. Like in the last video, I didn't like told that ideally if we just needed this capacity, we could have gotten it using self dot capacity as well, right? But we have to make sure that we are passing it so that we have this overall differentiation that yes, this is now what I want. So I am passing in my rehash function. Yeah. In my rehash function, I'm specifically passing it. So we know that, okay, in rehash, it's going to happen. Great. We'll get the same result if we don't do it, but I believe that it is better because this is something which we have to control properly. If by any chance this capacity change doesn't get into this create bucket, that's going to be a problem. Now self dot size equals 0. Okay. Why do we need to do that? So pay attention. Let's say till now we have added 5 elements. Size will be 5. Pay attention what I'm going to do next. For each linked list head in old buckets, right? Current equals each linked list dot head. Okay, so I will explain what is happening here. I am going, let's say I'm on 10. I just extract this out. I am making the head as 49. Now I will keep on going and inserting till I am able to find none, because each and every element here need to be inserted. So what we have to do here, everyone, while my current is not none, okay, we have to make sure that we move it forward. So current is going to be current dot next. Okay, that is fine. But along with that, what we have to do, self dot insert current dot key current dot value. Great. So we will go back to insert. Insert is going to find out this hash function. In this hash function, I'm doing this self dot capacity, which is a changed variable now. Okay, everyone. So I will just explain what is going to happen. When we insert it again, okay, it is going to go to insert function, which is here. We are going to calculate the bucket index. It's going to the hash function. Hash function internally uses this capacity, something which I have doubled here. So that problem which we talked about, okay, after rehashing, the hash index, that will get handled here because everything is going to now go to the right index. Now, once this is done, we can actually return. That is fine. Just one thing more, y size is required to be 0. Pay attention. When we are saying that insert here, it's going to increase my size. It was 5 initially. I am reinserting those 5 elements. Okay, so I will be reinserting these elements. Pay attention, let me zoom out. Yeah. Apple, orange, banana 2, banana 3. If I am reinserting them, don't you think that it will also increase the size again? So, for that particular reason, these small things we have to handle and the size we have to make 0. Okay, reset size before reinserting elements. So, I made sure that these comments are also there for the specific things where we can make the mistake. Okay, so great. Let us test this out, everyone. How can we test this out? There are few ways we can test this out. Okay, let me showcase that. For each LL head in Hashmap, okay, print each LL head. So it's going to show me 5 heads initially, right? We are pretty sure that here the load factor will become 0.8. It's 5. We are adding this particular fourth element. At 0.8, rehashing should happen. So let me just print the heads here as well. Okay, great. So let us run this, everyone. What is saying object is not iterable. Where exactly? 90 line. Okay, for each head in hash map. Okay, I will have to, this hash map is not iterable. So range of length. Okay, no worries. We have actually written this in traverse. So when we print our length, right, we can check it from here. Great. So let us check that using length, everyone. Should be fine. So now let me run this. See, 0 initially, load factor 0.2, 0.4, 0.6. It, when it became 0.8, what would have happened? Pay attention. So we would have started with a 1 minute. Yeah, we would have started with a array of 5. Once we entered these 4 elements, these 4, we notice that the load factor on my hash map is increasing. So I should have made it double 10. Now I start to re-enter these 4 elements, right? If I enter the first one, it is completely empty. I entered the first one. N is 1, bucket P is 10. 1 by 10, 0.1, 2 by 10, 3 by 10, 4 by 10. And finally, when I insert this last one after rehashing, this is where 0.5 is. Okay, everyone. So I hope this thing is clear. Just to showcase you that here rehashing has been completed. What can we do? So when we do rehashing at insert, yeah, let us do this and print rehashing done. Not done. Done. Let us go back, everyone, and just match these drawings. Yeah. See. If I run this again, it is saying after this 4 that rehashing has been done. And the fifth one is now added into this new overall 10th. Okay. The length is actually 5 because length gives us the size, not the capacity. What we can do though is we can see this hash map and see this hash map. Let me run this now. So pay attention, everyone. Initially, it was none, none, all were none. Okay. After that, 1 minute, we have it confused. So we have this. We can just comment this load factor for the time being. So where we are printing this load factor. Right. See, rehashing. Okay, it did rehashing. Now we are not printing anything, and rehashing is done. We started with a 5 sized hash map, but now see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we have missed. We have to expand it. Okay, so this is 1 only, right? Now you will be able to see it clearly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has increased in length with 10. And this is the exact each and every head. So there is a overall 2 elements in this one index, but you are able to see that more or less they are a lot uniformly distributed, right? Again, if you will try to increase lots of elements, then this will also get rehashed and we will have more spaces overall. So that's the overall benefit or idea. They are not all going to the same, I would say this thing, same linked list, right? If I run this again, maybe all of them will be separate as well. See? So now also 2 are going to same. Now also 2 are going to same. Okay, seems like something gets same only, so should be fine. Yeah, now 3 going into the same. So we can run it a lot of time, but yes. Normally I see that, okay, now see. We have run this and everyone has went on to a different one. And now you can imagine that, see, calculating that hash function is pretty straightforward. Once you get the hash function, then you just have to go to that index. It doesn't matter what the length of this is. Okay, and that's the whole idea behind Hashmap, that in an awesome way, we get a overall good time complexity. Okay, everyone. So I hope the rehashing concept is clear. Now you can remove these things. I'm just commenting them for the time being so that this is not how, like, our end user should not have any idea, right? Internally, the dictionary will also be doing some rehashing, but we never get to know about that. So just let us check the other function as well, everyone. Let us now comment this thing, comment out on this thing. Let us not print the hash maps. Okay. And let us just, first let us check the get function. I don't think any change should be there. It is working absolutely the way it should. And I'm able to get all the values. Okay, so we have seen rehashing is happening. We have seen insert is working fine now. Search is also working fine. Get. Okay. Now let us check for this as well. And great. So yeah. Seems like delete or remove is also working fine. If you will just go through the code, you will understand that actually no changes are required there. Apple is removed from hashmap. Key is not found now. Size has become 4. If you want, you can see the hashmap after this. It will be again a 10 size only. And key not found after 4. There are 10 elements. Okay. Everything is, I think, yeah. So there is a 2 elements which are at the same place. But after that, everything is more or less uniformly distributed. If you just have this size as 3, then I think 3 by 3 and finally 5 by 6. So 2 time rehashing will happen. And finally, we will have a 9 size hash map. So see, here it will be, it would have become 1 by 3 in this, then 2 by 3, then 3 by 3. Okay, so at 3 by 3 rehashing would have happened. This would have become to 6. Then at 5 by 6, okay, at 5 by 6, it is 0.8333, which is greater than 0.75. So 6 would have become 12, I guess, right? So it should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything is separate. And there are 12 linked list or 12 is the head bucket length in my hash map now. Okay, everyone. So pretty sure this is clear. Now what I would expect you to do is write this code once at your end. Again, properly just write the rehashing code. Believe me, I have tried to keep it a lot easy so that each and every one of you are able to understand and tomorrow explain it to anyone in any interview. Once this is clear, we have to still use dictionary only, the inbuilt one. But I hope now you are able to appreciate that what exactly goes behind dictionary, right? That is the whole idea behind learning this DSA. algorithm and data structures, because it helps you to answer that why things are happening the way they are happening. And now you are equipped with the knowledge through which you can actually use that and implement some good complexity data structures or functions, right? So in the questions, you will still be using this dictionary only, but this is asked a lot as well as used a lot, the idea behind this. So please make sure that you do practice that. Now you will also have many assignments which you have to do using a simple dictionary, but I'm pretty sure that now your overall idea, your overall mindset will be a lot clear. Okay. So great, everyone. I hope that is clear. Now, let's meet in the next video. Thank you.